Hey everybody. I'm your host, John Myers, live from Stillwater, Oklahoma. We have got a great show tonight. It's John Myers. Hey everybody. Gotta have my notes. It's John Myers from the Kicker UnMasked studios. Gotta have my notes. Alternator. Hey everybody. We have fun. Hey everybody. Hit like and subscribe. Right here, right now. It's John Myers. We like to give stuff away. Alternator. Post some more pictures. We got to thank Steve and Becky live from Stillwater, Oklahoma. Don't forget Texas Roadhouse right here, right now. Hey everybody. Don't forget right here, right now. We have got a great show tonight. Hey everybody. Had a great dinner tonight. It's John Myers. Right here, right now. Had a great dinner tonight. So, hey everybody. So, housekeeping. Had a great dinner tonight. So, alternator. Housekeeping. Housekeeping. 7:30 on Tuesday night. Housekeeping. From the Kicker UnMasked studios. Housekeeping. Right here, right now. Hey everybody. So, it's John Myers. Hey everybody. It's John Myers from the Kicker UnMasked studios. Hey everybody. From the Kicker UnMasked studios. It's John Myers. Right here, right now. We have got a great show tonight. Hey everybody. We have got a great show tonight. It's John Myers. Hey everybody. Right here.
Good evening, ladies and gentlemen. Thank you for being here. It is Tuesday, 7:30, Facebook, YouTube, Instagram. Oh, wait, no, it's the teaser. Different mode altogether. Thank you for being with us tonight. You have probably heard that Mr. Bill Frog is no longer with us, and I already miss him, quite seriously. We had beers together on Friday, last week, I guess it was. Long holiday weekend. Had a great time hanging out with Bill. He's not leaving the area. He's just leaving the building, so to speak. So we're going to miss him. Maybe he's even watching tonight. But in the studio, who do we have? Of course, we've got Stephen Bambrow. He is working the cameras. He also has a bag of frozen peas with him. Haven't figured that out just yet, but he does have a frozen bag of peas. We've got Ernie, of course, working the magic keys back there. And, of course, also JW, who is filling in part of Bill's job as well as his own job. And he provided a fantastic dinner tonight. And I cannot forget, we have a very special guest in studio and in lab today, Mr. Joe Hobart. I asked him how to introduce him, and he said electronics janitor. So we're going to call him the electronics janitor. So that'll be Joe Hobart. He'll be here in the studio with me. We're going to chat a little while together, and then we're going to go to the lab so he can do some deep dive stuff on the Warhorse amplifiers. And it's pretty rare, but we actually have a studio audience tonight as well. Mr. Aaron Surratt, who you've seen on the show several times, he is in the studio tonight hanging out with us. And Jacob. Jacob is a young man that loves audio. He has a passion for Kicker, and he wants to learn more about what we do. So he's been job shadowing Aaron for the last couple of months. So he's in the studio hanging out with us tonight as well. So we're going to take a short break. We're going to get Joe here in the studio. He's in the green room getting massaged right now. He'll be here with me shortly, so be right back with us.
It's been a long road since the original Kicker christened that first pickup truck. kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machine became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
Music is my passion, my livelihood, and it's in my DNA. My pals at Kicker Marine Audio gave me a chance to take the music, what I love and listen to, at home, on stage, and in the car, onto the water. Hi, this is Jason Bonham, and I want to say a big thank you to my friends at Kicker Audio for inspiring the songs and the stories behind the music that inspires America. Go overboard! This is your time.
Little John cannot stand on his own 2 feet. Welcome back. Thanks you all for being here again. Of course, this is Mr. Joe Hobart, the electronics janitor. Joe, why are you the electronics janitor?
Well, I get to clean up all the stuff around here. That's my job, right? Whatever it takes to get the job done, that's what we do.
Okay, well then, yes. Now, I have seen you push a broom, and your car is spotlessly clean, and your house is immaculate, so I think janitor is appropriate.
That works.
So, you guys and girls, you've seen Joe on the show before. Normally when Joe shows up, smoke comes out of the electronics, the magic smoke. Now, Joe, are we going to let smoke out of something tonight too?
Highly doubtful.
Unlikely.
Unlikely.
Because tonight we're only going to abuse Kicker product.
Correct.
Which is designed for abuse.
Yes, we like to abuse our stuff dramatically in the lab, so shouldn't see any smoke tonight.
During the tours, I like to say that we abuse our stuff, so when they abuse it, we know what's going to happen.
Yeah.
It's going to be fine. So obviously the topic tonight is Warhorse, and we want to do a deep dive with Joe Hobart on what exactly is Warhorse and why does it exist. So Joe, first of all, what is Warhorse?
So of course, most people know Warhorse from our 10,000 watt amplifier from what, 20 years ago now maybe?
2008?
Yeah, so 18 years ago. We were probably working on it 20 some years ago. Seems about right, because I remember when I got here 18 years ago, we were just getting ready to release it. And of course, that was our SPL competition line back then, right?
Yes.
That Warhorse was very unique, as in that it was a half-wave drive amplifier. So one half of the amplifier would drive positive, one half of the amplifier would drive negative, right? It was very unique and required unique applications to make it work, to make it really, really efficient. Well, the new Warhorse amplifiers are based on today's technology with today's needs, right?
Sure.
Lithium has come around, power's gotten cheaper. We don't have to quite be in that 92% efficient area to try to make something work, but yet cause issues on the install side, right?
Right.
So these are traditional amplifiers, traditional push-pull. We have 2 amplifiers here, of course. We have the 3601 over here, monoblock, very conservatively rated, as you guys will see tonight, and 1004 4-channel, also pretty conservatively rated. As we will also show tonight. Both of these amplifiers use some of the latest technology in Class D possible and some of the latest tech from us. Both of them have symmetrical power supply and output stages, which we've talked about in this show before.
What are the benefits of that real quick?
The quick benefit to that is, so when you're making a lot of power, pulling a lot of current, you really want both the positive side of the rail and the negative side of the rail to be as even as possible to limit spiking and to make losses match. Because if spiking gets too big, you can have what's called avalanche effect happen to your MOSFETs. When that happens, you're basically, it's like peeling out your tires every time you take off, right? You're not going to kill the FET right away, but every time it switches in that mode, you're taking a little bit of its life away, right? So instead of having an amplifier that lasts you for 10 or 20 years, like most of our amplifiers do, you'd have an amplifier that lasts you for 1.5 years through your warranty period, or 6 months, or 2 days, or depending on how bad how hard into avalanche spiking you get. So that is one of the biggest things is radiated noise, avalanche spiking, and symmetrical power supply deals with a lot of that, makes it better. Symmetrical output layout, kind of the same thing. You get the same thing out of the left rail as you get out of the right rail. Everything flows evenly through the board, right?
Oh, in the lab, you're going to show us what you're talking about, right?
We do not have an amplifier open right now.
Oh, we don't? Okay.
We can open up one of these if you guys like while I'm in there, and you guys can show it on the backside, or we could come back after the lab if we have time and show one opened up.
It's beautiful. That's why I brought it
They're
up.
very pretty, yes.
It's gorgeous layout.
We can definitely open these ones up and show them before we leave. Both of them are based in that same type of design. 3601, of course, has 4-fan cooling, which is microprocessor controlled, so it's not just on and off. It's PWM'd, so the fans will slowly ramp up depending on temperature and input voltage. So if your signal gets really big, we'll preemptively turn the fans up higher to pre-cool everything to keep up with it, right? So these amplifiers should never really ever thermal. If you get this amp to thermal, I want to know how, because even in the lab running fixed loads, we have to put a blanket on it to get to thermal to check thermal recovery.
Yeah.
This amplifier, about half the power, doesn't need fans. Still same thing.
Plenty of heat
Plenty of heat sink. Doesn't get hot.
When you mentioned hot, let's talk about this real quick.
Both of them come with, of course, as you see Aaron playing with here, is a diagnostic module, as well as, of course, the sub-amp comes with a bass knob. The diagnostic module can show you quite a few things. The first is, of course, your current voltage, along with what you'll see here is a little button to push. This will tell you your highest voltage that you've had during this ignition cycle and your lowest voltage you've had during this ignition cycle. The advantage to this is most meters do an average.
Multimeters.
Most multimeters, yeah. So if you're putting a meter on something and you're trying to do like min hold or max hold on the meter to watch because the amp's turning off or something's happening, even that min or max number is an average of a few cycles of time. This will be much more accurate, much faster. So if you have an amplifier shut off and you go back here and you go back to your diagnostic module and push the button and you see that you went to 9 volts or something, right? You'll know what happened. Also has, what you have here is, of course, there's a thing that's called PS and below it amp. Those are the two main protections on an amplifier like this. PS means power supply protection. That should really never ever come on unless you have a shorted speaker output, a completely illegal load, or something catastrophically went wrong, right? The amp one is for the Class D outputs, and that will come on if somehow you pull more current out of the Class D than you should. Illegal load,
Yeah.
pretty much blown speaker, the two ways that could ever happen. Once that happens, if you remove that short or turn it down to get out underneath the undercurrent, that one will go away and go back to working. The temperature gauge, which what started this conversation, is on here. In normal operation, this will be green. If the amplifiers actually get hot enough to get to where we call them getting close to thermal, they'll go orange. If they actually ever hit thermal, that light will turn red, so you'll know why your amplifier shut off. Sure. You don't have to go back there and put your hand on it and come away with some marks on yourself. So it's a great tool. They're magnetically mounted, so even if you have 6 of these amplifiers, you can snap them all next to each other, and they can all mount up on the same panel like that. Same thing with the bass knob. They're magnetically mounted, can be mounted right with them. Makes for a nice install option, however you want to do it. This thing also can come apart and be front mounted, so you can cut a square in your dash and panel mount it. Same thing with the bass knob. It can be done like our traditionals, where it can be stuck through a hole in the back, cut out so you can keep the pretty face, and flush mount it with the face on the front,
Right.
or
Custom.
use it as you want it, right? Either
Now,
way.
correct me if I'm wrong, Joe, but this idea came from the competitors that we talked to. Is that correct?
Yes, I mean, most of the features on these amplifiers came from what I guess we'd call the kicker competition group at this point. At that point, they were just, I think, a bunch of guys that signed NDAs.
Yes.
At that point, that we were discussing what they would want in an amplifier, what they'd want in a speaker, that type of stuff for the SPL world, right? So both this and the competition mode feature all come from that group's request, right? And the competition mode feature, if we've talked about it before, but basically there's a button on the end that you can push. It bypasses the crossover to the absolute maximum highest frequency. So on the sub amp, it's 200 hertz. It locks the input gain at 4 volts. So the gain knob no longer does anything, so you can't have gain creep or crossover creep in a high pressure SPL vehicle. And it really allows you to set up all your amplifiers via DSP, no matter how many you have, very quickly and easily.
Like
you know,
Drew?
yeah, you know exactly what the sensitivity levels are. You know exactly what they need. You can set them all the same, and off you go.
So at that point, it's just raw power.
Yeah, it's just a power
No
amplifier
preamp.
at that point, basically, yeah.
And you can also defeat the subsonic filter, correct?
Yes, this subsonic filter is defeatable. It goes all the way down to 5 hertz when you turn it off.
Hair trick, anyone?
Not sure how we're going to find some music that will reproduce that frequency, but if you do, great. Yeah, let's go.
Tone generators,
Yeah,
right?
tone generator, that works. Yeah, let's go.
So very unique features in these amplifiers. In the teaser, we said these are the most powerful amplifiers we are currently producing. And in the 4-channel, I think that's actually the biggest 4-channel we've ever made. Is that correct? At least
Yeah,
since you've been
it's
here.
the biggest 4-channel we've ever made, period. It's
Yeah.
not even close, yeah. We rate these, we call them 1004. That's because they're 250 watts by 4 at 4 ohms. They're almost 500 watts by 4 at 2 ohms.
Yep, yep.
Bridge, they're all about 1,000 watts a side, right? So you really have 2,000 watts of power here
Yeah.
to run your mids, or a mid and a sub combo, or whatever you want to do.
Yeah.
But
Crazy.
lots of power, yeah. So plenty of power to run any mid I can think of. Our STs, you're still gonna have to use a couple of them.
Yes.
Right. This is gonna be extremely loud.
Well, and something I like to talk about in the training when we're talking about these amplifiers with our retail partners is if you want to get into Warhorse amplifier technology, but you don't yet have the electrical system requirements, which we'll talk about, to power up the 3601, you could actually use the 1004 as a 3-channel amplifier.
Yeah.
Bridge 2 channels to a single Solo X10 or Solo X12, and you've got almost 1,000 watts RMS to run that subwoofer. And then you've got another 500 watts RMS at 4 ohms to drive your front stage. So you can have an incredibly powerful audio system without having to do massive electrical upgrades by using the 4-channel.
Yeah. And that's something we actually see a lot in Europe with smaller amplifiers. So it'll be really interesting to see. They take like our 364 and 800 forwards, and you do a lot of tri-amp setups like that. We don't see that in the US quite so often,
Right.
but it'll be interesting to see if that becomes more popular with this type of power.
So Joe, we got a bunch of spec sheets and tech talk. One of the things we love about having Joe in the studio is that he's incredibly smart, and he also likes to share that information with why we do what we do with these amplifiers. So we've put together a bunch of information that we can share with you guys. What should we start with, Joe?
Probably start with the tech sheets first, just so we can.
Okay. You want to do the 4-channel or the 36?
Yeah, let's do the 4-channel first.
Okay. Ernie, can you pull up my laptop for the audience? Can you see that, or should I make that
Can you
bigger?
zoom that in?
Yeah, we can.
One graph at a time, maybe?
Yeah, let's do that. Okay, there we go.
Okay. So what you're seeing here, of course, is what's called an audio precision power curve. It looks at THD versus power. And this one has 3 impedances on it. If you guys have looked at home amplifiers or some certain other brands, there are some brands that will show something like this, especially in the home audio world. So what you'll notice about this amp, especially for an SPL amplifier and being a big sub, this is the 4-channel, big 4-channel amplifier, the THD starts below 0.1 THD, even from the beginning, right? So that tells you the noise floor of the amplifier is very low. Power comes straight across, stays right about that 0.1 area, all the way until you hit what's basically the voltage rail of the amplifier. And on a perfect amplifier, this would be a flat line going over with a hard angle when it hits it. This is really close, right? It stays really low. When you get out of the what's called synchronized switching down low, about 10 watts, it changes to unsynchronized. That's why your THD gets right up to 0.1 there. As that comes across, you make flat power all the way until you hit the voltage wall. And as you can see, pretty much a perfect curve going up, each one of them until they hit 1% power. They continue to make a little bit more power as they go up to 10, as you'll see when we do the lab work today. All of these amps sound good, are clean, and have a nice low noise floor, so you're not listening to a bunch of hissing and popping and stuff going on in the background while you're working on it.
When we did our last Kicker U in-house training, one of our guests said, why is signal to noise ratio important in amplifiers? And this is a guy that does a lot of really big PA style audio systems. And so I said, you've got to think about when you're using super high efficiency output drivers like Street Series, they're very, very sensitive. If there's any noise coming from the amplifier, you're going to hear it in that system, especially at low volumes. And then when you crank it up, it just gets sort of nasty and crunchy sounding because all the noise from the amplifier is getting amplified. So to have 1,000 watts of truly clean, noise-free amplifier is incredible.
Yeah, it is. And on top of that, right, like what we don't talk about is gain. So what are you doing when you do gain? Right? You're making the amplifier more sensitive.
Yes.
So if the amplifier becomes more sensitive, what happens to the noise?
It adds more.
And so any noise in the front end, any noise in the amplifier, all of that gets louder and louder and louder.
Right.
So that's why you guys talk in training and why we talk so much about keep the gain at minimum, find a way to get voltage ahead of time, bring the signal up. Like, try to keep your amp gain low. The best signal, the best sound you're going to get is when the amp's gains are at min and everything else is set up in front of it to keep the voltage high and the noise low.
Right.
So that's an important thing when you're trying to get loud without having hiss.
So, Ernie, can we go back to my laptop? Let's go down to, whoops, we jumped a couple here. Is this the next one?
All right, yeah, so that's power bandwidth. So this is a test that probably a lot of people have not seen, but this is pretty much the industry standard now for how you power test an amplifier. And the reason being is a lot of amplifiers won't make the same power at 40 hertz if they do at 100 hertz or if they do at 1,000 hertz because of the way the output filter or the impedance or the power supply works. And so what the industry has done with what's called CTA 2006D has gone to basically power bandwidth testing. And what that allows you to do is to sweep the amplifier at full power and look at the frequency response across it. And what you're traditionally going to see with a Class D amp is you're going to see a little roll off at the top end or a little bit of boost depending on the filter. And roll off on the low end will be the subsonic filter.
Okay.
Right? In most cases, or whatever the subsonic, because every Class D amp has a subsonic filter, whether they talk about it or not.
Sure.
There is one there, right? It's just where it's at. And as you look at this, we're less than a dB down at 20 hertz. That's our subsonic filter on the low end coming into play. And it's completely flat up to the top end to where the output filter becomes into play.
There we go.
And with a Class D amplifier, they all have a filter on the output to turn the triangle waves back into audio, right? Depending on how that filter is made, at some point you'll either get a roll off on the top end or a little bit of boost. And the goal is to always be within 1 dB one way or the other is what you're trying to shoot for at your rated impedance. Because as the impedance changes, that curve will change on the top end. And so we always shoot with a 4-channel amp at 4 ohms to be within 1 dB plus or minus all the way out there. And of course, this one is as well. So it just shows you're going to make the same power across the frequency spectrum and get what you paid for no matter what frequencies you're paying, basically.
So we've got a question that I want to bring up before we go any further. Ernie, can you pull up the first question? Or JW, can you pull up the first question there? Good evening, Andy. Thanks for being here, buddy. Is the 1004 the same size pretty much as the 3601?
Identical sizes. They fit the same footprint.
Good question. So yes, if you're looking for symmetry in your amp rack, you've got it. Thanks, Andy. Good question. Next question. Timothy. Hello, Timothy. What is the damping factor of the Warhorse? This is something you love to talk about. Thank you, Timothy. Joe loves this.
Yes, dampening factor. So the problem with dampening factor is it was used and marketed through the 70s and 80s as a high-end spec. The more efficient you make the amplifier's output stage, i.e. the Class D side or the AB side or whatever it is, the lower your dampening factor will be. You can make it higher by adding a bunch of mass on the output side, actually like a big toried transformer or a bunch of copper or a ton of wire bundled up. Your dampening factor will actually go up. But the reality is the amplifier's dampening factor has almost nothing to do with how it sounds or how your system will sound. Because no matter what the output impedance, which is what dampening factor is really measuring, will be in the thousands, whereas your speaker's impedance is in 4 ohm or 8 ohm or 2 ohm or 1 ohm.
Right.
And so when you do the math, the difference between an amplifier that say has 1,000 dampening factor and an amplifier that has a dampening factor of 1 will be like 0.001 millivolt. So yes, it's a spec that you can measure. Unfortunately, it's a spec that's been marketed as why some things sound better than others, but it's actually not the case. it's one of those marketing specs that I wish would just kind of disappear because it really doesn't have anything to do with how the amplifier sounds or performs. We actually have an amplifier in the KX line that when you do the math and measure it, the dampening factor will actually be negative.
Negative.
Because it's that efficient on the output stage. So it's one of those things where it's like, it was used in AB amplifiers, it might have had something to be useful for, right?
Yeah.
But in modern electronics at this point, that spec really, unfortunately, is misleading in most cases and useless, if not less so.
Timothy, I love this question because when I first went through amplifier training back in the pre-Cambrian era, I was taught damping factor was critical to the performance of amplifiers. And so I went most of my life thinking that it was. And then over dinner one night, Joe schooled me because he heard me say it. He's like, Aaron, you got to stop saying that, and here's why. And so I'm like, whoa.
I came from that same school, right? I grew up 70s, 80s, 90s, right? And that was something that we were all preached and talked to.
Yes.
Until I started really getting into the design side and the physics. And then you start doing the math. And I've posted it before on Andy Weinmeyer from Audio Frogs posted his own version, which are very similar from two different places.
Sure.
And unfortunately, it's one of those things that it doesn't really make a difference.
Yeah.
You're better off looking at like intermodular distortion, FFT, those type of things, right? To tell you how an amplifier is going to sound than dampening factor ever will. The biggest thing with an amplifier, to be honest, is have enough headroom and low enough noise floor and a flat power bandwidth. If you have those three things, it's going to sound pretty good. Better than most people will be able to tell apart, right?
So, Joe, I'm looking at the clock and I'm realizing we want to get you in the lab.
6 minutes,
So let's look at the FFT real quick that you referenced.
So FFT here. So what this is an amplifier playing a single frequency, and you're looking at the full, basically most people call it an RTA, but it's really called an FFT. And the FFT has more bands than RTA, but it looks at the whole spectrum completely. But this can be thought of as an RTA. We're playing 1K. It's plus 20 dB, and that's 10 watts actually is what that's at. And then you're looking at the noise, and you're looking at the harmonics created above or below it at that frequency. In this case, you'll notice there's a harmonic at 2K, 3K, 4K, 5K, and then the other ones start to die way down at that point. There is an ongoing long-term argument of some people think even harmonics sound better than odd harmonics, so forth and so on. I won't go into that argument tonight. We don't have time nor bandwidth to do it. But in this case, what we really are looking at is, so we're at 20 dB positive, right? And we know every 3 dB is a lot more energy. The first harmonic, the highest harmonic is at negative 60 dB, so it's 80 dB down. If anybody's used one of our bass knobs, they have 26 dB of attenuation. When you turn the bass knob all the way to the left, what do you have? Zero bass. So if you have 80 dB between your signal and your harmonic, do you think you can hear it?
Absolutely not.
Exactly. And that's really what this is just showing, right? Very quiet amplifier, clean harmonics, nice and low. Going to sound good for you.
So a poorly designed amplifier is going to have these spikes be much, much higher?
And probably wider in quite often in cases.
Okay.
You'll get a higher noise floor, higher ringing effect of the devices that are around it. Yes, sir.
Okay. Crossover bench?
This is just showing all the different crossovers in the 4-channel. As you can see, there's no bumps in these at the top where the hump starts to happen because these are Linkwitz-Riley crossovers. They're designed at 24 dB, so they'll keep you in phase. If you're maxing mids to a sub or mid basses to a sub or mids to a mid-range or tweeter, your phase is always going to be electronically in phase. You only have to worry about your acoustic phase.
Acoustic phase, yeah. Nice. Okay, down, next one.
Same thing for the rear channels. There's a few less crossovers on the rear channel option.
It's important to point out at this point that the amp 1 and 2 can be used as tweeter high pass, so there's a ×10 multiplier. So basically if you want to take 500 watts RMS to your tweeters, you can do that electronically through the amplifier. Yeah. And then channels 3 and 4 are band passable. So you can do a low pass and a high pass filter, so you can do an active mid-range or a mid-bass setup with the amplifier. So all this is built in, so you don't have to use a separate crossover if you don't want to, or if you're just doing a simple system and you don't need all that extra stuff, it's built in.
Correct.
All right, so that covers, is that all the?
I mean, the 3600 one's going to look exactly the same. just its graphs are a little different, right? This amplifier, if you pop that one up there, this is about as closest to what I would say I've seen as a perfect amplifier. You'll notice that when it hits the voltage rail, like everything starts out under 0.1, goes all the way down to almost 0.01 as it comes across. And when it hits the voltage rail, it pretty much goes up, right? There's no wobble, there's no hump. It's a nice sharp corner. This is a very well designed amplifier, no matter what amplifier it was. For it to be a large sub amp, it's impressive. Fernando did a great job.
Thank you, Fernando.
Same thing, power bandwidth. You notice we have a 200 hertz
right there.
Yeah, crossover on it. Once again, it's Linkage Riley. You'll notice there's no hump in it as it starts to go down. If you're not aware, of course, you measure that from the 3 dB or 6 dB down point, depending on which time of crossover it is. That one's 6 dB down. Here is its FFT signal. Once again, this one's 50 hertz because it's sub amp. So you're at plus 10 on this one. And your next harmonic is negative 670-ish?
Below, yeah, about 70.
Negative 70-ish, right? So you got an 80 dB window there again. And after that, the harmonics drop off even farther with this amplifier.
So when the bass drum kicks, you just hear the kick and that's
the
it.
bass drum, yep, nothing else.
No overhang. And the
Crossovers once again.
Clean and tight. All right. Is there anything else we wanted to show before you head to the lab?
Well, there was a couple things that I think we wanted to touch on real quick. And
Okay.
We're probably going to run a few minutes over,
It's
but
okay.
let's do
do
this.
it.
So there's been a lot of talk online versus Brazilian, Korean style amplifiers. In reality, that's really half bridge amplifier design and full bridge amplifier design. Unfortunately, full bridge amplifier design has gotten kind of a bad name in the last 6, 7, 10 years because of some designs that were kind of what we would call on the ragged edge, right? They're not as reliable as they should be. I will just say this. If everything is designed equally between a half bridge and a full bridge, they're going to be exactly the same type of reliability. And the easiest way to explain this to somebody is if you take two half bridge amplifiers that are strappable and strap them together, what have you just done?
Full bridge amplifier.
You've made a full bridge amplifier. That's the only thing that's different in a full bridge is it has two Class D drivers and a little bit different power supply rail because you're driving positive and negative, and that's it, right? They both use the same Class D sections. They're both using the same output chips if they're the same identical designed amplifier, right? It's really not full. It's not Brazilian versus Korean. It's half bridge versus full bridge. And they're basically the same, just one drives both the speaker positive and negative, and one drives just the speaker positive until you strap it, and then one amp drives the speaker negative, and the other amp drives the speaker positive. Advantages and disadvantages to each of them. Full bridge amplifiers can be made smaller. Normally you have more parts, but they can be made smaller because they're a little more efficient, take up less space. Half bridge amplifiers can be bigger. They're kind of an older technology in some cases, right? But they all work with the same parts. There's not potato, depending on how you design them, really, right?
So what classification would the Warhorses?
So in this case, right, so the 4-channel amplifier can be bridged. So what's that mean? It's a half
It's
bridge,
a half
right?
bridge, yeah.
The mono amplifier can't be bridged, and it drives both the positive and negative, so this is a full bridge amplifier.
Okay.
This would be what we would consider to be a robust, reliable full bridge design. And we've been making both full bridge and half bridge designs since the late 80s. So the full bridge isn't new, right? We've had it in a lot of our amplifiers for quite some time. The Key 204 is full bridge. The 808 KXMA amps, full bridge. There's some other ones in our line that are full bridge. It just depends on what was needed and what was wanted in the specs, whether we go full bridge or half bridge.
Okay. And there was another thing. Oh, we had a question I wanted to mention about clip indicators. JW, can you pull up the clip indicator? Aaron T. Hello, Aaron. For the Warhorse amps, why didn't we include a clip light on the amp? This is a great question. Thank you.
Oh, we're going to be really late. So traditional clip indicators in most amplifiers that are out there, not our KX, but probably most everything else, KX and Key are different, but in everything else, it's really a comparator that looks at input voltage versus gain stage and says, okay, the output is going to clip here. Now that's great for setting gain on a normal system. It gives you at least an idea. You're going to be somewhere close, but what you can't factor into is impedance, voltage drop. So in your math, right, like, so we set it up at 14.4 at 1 ohm. If we have 5 volts of input with the gain set here, so the voltage after the gain is this, this will be clipping because this is a fixed gain stage after the gain stage.
DSP.
Right? Everything's fixed. So you can take that educated guess and set that up. The problem with an SPL system is, one, most people clip. Two, intentionally,
Yeah.
yes, because it's all about SPL. It's not about running a clean system.
Right,
Two,
right.
most of them, you're either over 14.4 or way under, depending on whether they're a daily ground pounder or a lithium bank monster, right? And that light will be on all the time. So after talking to the competition team and going through the feature sets they want, it was something that none of them would use, because even if we did do a clip indicator and you bought 4 of these Warhorse monoblocks, there can be a variance. This amp's 4,507 watts at 1% THD. I've seen other ones at 4,800. I've seen ones at 4,400. So there's a 400 or 500 watt spread.
Yeah.
Just between manufacturing tolerances on an amplifier of this power.
Sure.
So if you have 12, 10, 15-inch subwoofers sitting in there, and you have one of them wired up to each pair of amplifiers, and you got 6 amplifiers, if you just use my clip light, some of those are going to be getting 400 or 500 watts more than other ones.
Yes.
So they won't be even, and you're going to have some subs that are going to either toss coils or get damaged before other ones do, and you wouldn't really know why, right? We set them up with a clip light, this is good. Most of the big SPL guys use voltage, right? They'll put in a fixed signal, they'll go through and adjust the gains on each one of them until they get the same exact output voltage, and they call it a day. And that is actually a much better way to do it if you're doing multiple sub setup. Right. If you're just doing one amp with one set of subs, okay, a clip light makes a great idea, and maybe we missed that for the individual ground and pound guy. But if you're doing multiple amplifiers, you really want to do something that's more robust and reliable, sophisticated than that. Yes.
Awesome. Great. Thank you for that question. All right. So, Joe, unless there's anything else we need to talk about,
I don't think so.
Send you to the lab.
All right.
Hey, folks, we're going to take about 2 minutes. So run, grab a fresh brew, maybe go to the restroom, and then come back. Joe's going to be in the lab on the headset. So stay tuned.
Kicker Performance Audio. For almost 50 years, we've been rocking the planet with our world-class product covering everything that drives you, whether in your car, truck, boat, motorcycle, side-by-side, or even on your head. Kicker Performance Audio's passion for bringing you your favorite music like you've never heard it before is what drives us. So wherever you need us, Kicker Performance Audio will be there for you.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machine became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
Music is my passion, my livelihood, and it's in my DNA. My pals at Kicker Marine Audio gave me a chance to take the music, what I love and listen to, at home, on stage, and in the car, onto the water. Hi, this is Jason Bonham, and I want to say a big thank you to my friends at Kicker Audio for inspiring the songs and the stories behind the music that inspires America. Go overboard!
Welcome back. Hey, there's Joe. Joe,
how's
welcome.
everybody?
Welcome back. You look good in the lab, man. Looks like you're home. So, Joe, what are we going to do first?
Well, we're going to do something that, to my knowledge, has not been done before. We are going to amp dyno an amplifier at the same time while the AP logs what's happening.
So simultaneous testing with the amp dyno and the audio precision.
At the same time, yes.
Okay.
And before we start this, we want to talk a little bit about how the amp dyno works.
Okay. I've got some graphs to show.
You've got some graphs to show, which I can't see in here, but I'll let you pull them up. So the first one is, we're going to talk about certified and uncertified power. So if you just pull up the one that shows the 10 seconds of the certified track, please.
I think that's the spreadsheet one.
No, the other one.
Oh.
The one that kind of shows the overview, and then we'll go to the one that shows the...
Okay, certified track, 40 hertz.
Yep.
Okay, it's up. Go ahead.
So I can't see that, but I'm expecting you should see a track that starts at 5 seconds and gets bigger as it goes up to 15 seconds. So it's
Correct.
a 10-second long track, right? So that is the certified and uncertified track from Demore and Steve Mead. That is the file that you play. I can see that now. Thanks, Stephen. That is the file that is played when you are doing an amp dyno test for certified and uncertified. It is a 40 hertz track and there's a 1K track. So pick either one of them. They look that same. Now that's zoomed out real far so you can see all 10 seconds of it. So let's look at the next file that we have that has it broken down.
Okay.
Oh, that's fine, Stephen. This will be on air.
It's coming up now.
Yep. So this should be...
It's very small. Sorry, Joe.
No, you're fine. There it is. Yep, that's good. All right, so what you'll see there... That's fine right there. What you'll see there is the beginning of the track. You'll notice that it starts out at negative 25 dB. And then 5 seconds into the track, you'll notice it gets to about 10 dB. So it's still negative 10 dB. It's gained 15 dB in output in the first half of that track, right? And then the last image on the bottom of that screen is the last second of that track. And at the last second of that track, you'll notice it gets close to 5 dB all the way up to 5 dB. So the last second, it's like 4 dB up to 5 dB. And that's that track climbing to the end. Now, why is this important? So when you set up an amp dyno and you follow their instructions, it tells you to set up at least 5 dB of overlap. Well, overlap is there so you can make sure that if something's not recorded all the way at 0 dB, you can still get full power. It's used quite often with our installers or in the field to make sure that you get the most out of your amplifier without clipping too hard. But yet still not going crazy on the clipping. Because if you set your sub amp, especially by ear, most of the time you can't hear distortion until it's 15 to 25%.
Absolutely.
So you're way into clipping on a sub before it kind of changes that tone. Like people, you can kind of hear where it gets obvious. When it gets obvious, you're way into clipping. You're 25, 30% most of the time. So setting on, especially on a subwoofer, gain by the ear is very hard to do. So this is a setup, along with his other tools that he has that allows you to do gain overlap, right? So for the amp dyno, he says do at least 5 dB. Somebody like Big D, he uses 8. That's actually what we've done today, so we're kind of matching what he does. So there's enough overlap to make sure you get into clipping and, but not crazy over clipping. So if you look at the little Excel sheet that I made for you, we'll explain why that matters in dB, because dB is 3 dB or 5 dB is a much greater value than power, and we'll kind of show that in this little chart.
There you go. It's pulled up.
Okay, so on this chart, you'll see if we were using a 5,000 watt amplifier, that at 5,000 watts, the signal input would be 0 dB. That gets you 5,000 watts in. it's out, if I remember right, because I can't see it from here, it's like 67 dB of output.
That's correct.
Yep.
Yes.
So if you go down 3 dB on the input, how much power do you have, Aaron?
2,500 watts.
Okay, and you go down 5 dB.
1,600.
Okay, so that's just 5 dB different. So while this track is going from negative 25 dB up, in that chart you can kind of see what happens here. It goes from 17 watts to like 100 and some watts, and it climbs up, but you don't get into any real power until that last couple seconds of that track, because dB values are so much bigger than a watt value is, right? It takes a lot of watts to make a dB. And so I can't see the chart right now, but I believe it goes like 25, 16, 600 or something, 570 or something, and drops real quick.
Yes.
As you go down there. So even 10 dB down at half the track is less than 1,000 watts.
Yes,
and
half 1,000 watts.
Yeah, it's 500 and some watts. Yeah. So really, for that 10-second track, if you have a 5,000 watt amp, you're really only pulling a lot of current in the last 1.5 seconds of that track, right?
Okay.
And so that's why you'll see the amp dyno number climb, and then the lights start to flash.
Yep.
Because you're only getting towards clipping in that last little bit, depending on the overlap that you got. So that's the important part about this gain overlap in dB. A couple dB here or there can be a lot more power you're asking from an amplifier. So go on the flip side. If you had a 25 watt amplifier and you set it up with 5 dB of overlap, it's going to be trying to make 5,000 watts, actually 6,000 watts, right? If it ever sees a 0 dB signal from its head unit source. So gain overlap is a powerful tool to make your stuff louder than it would be if you had zero clipping, but not too much clipping. But too much gain overlap can be very, very bad for the system.
Right.
And we talk about this because this actually will go into clipping some. And when you watch this together, you're going to see the THD line climb probably all the way to about 20% THD before the test actually stops on the SMD. And that's from the 3 dB of overlap that we have. So that's just 3 dB of overlap in this case, because we have 8. So it's set up a negative 5 dB track, so you minus 5 out of that. That's all that's left is 3. So this will be 3 dB of overlap, and what kind of power you try to get out of an amplifier if you actually play something that's recorded at 0. So we'll start that now and kind of show you what's going on here. So you should be able to see the amp dyno and the AP screen here in this screen. Power looks like it's a little high now. As I turn these back on, hold on. Let's get power down.
Oh, I can feel the heat from here, Joe. Jeez.
Yeah, 1,800 watts or 1,800 amps of current plus 2 kinetic batteries.
I hope Megan's not watching.
We're not calling it overkill. We're just calling it what it is. All right, so we're gonna do a 1 ohm mono test. So then this is certified. So we're gonna go enter here. We're gonna go start dyno. We're on track 4. We're gonna go, and then we're gonna start the recorder here. Now you'll see the recorder's going to start out really high on THD, and then once this track starts, if I can actually,
So on the left is the audio precision output screen. On the right is the amp dyno. Hey Joe, shall I take a question while you're
yeah, you should for some reason. Why is
Okay,
this
let's take a question.
Pause, play.
What do we got here? First question. Oh, okay, there we go. Paxton, good evening, Paxton. Can you use a Key 204 as a DSP for the 1004? That is a great question, Paxton, and the answer is yes. We use a 40 volt input on almost all of our amplifiers at this point. And that allows us to use the DSP in the Key 204 as a preamp. So you could use all the technology, the Key technology in the 200.4, and then use that, the output of that to go directly to the RCA input of the 1004. And yes, you'd have all that great DSP technology now with 1,000 watts RMS. So great question. Thank you for that.
All right, Aaron, I'm ready.
Okay, Joe's ready. Let's go back to Joe.
Might help a lot to turn the amplifiers on. There's so much there's so much humming in here. I didn't realize they aren't actually on. All right,
it's okay,
so
Joe. It's
that.
live.
Here we go. We're gonna start track 4.
So this is
start this.
This is a 3600 one you're doing, right?
Mm-hmm.
Okay.
And so we're gonna run this test twice. So there you said we made it to 14.19, so I need to up the voltage just a little.
You're upping the input voltage?
Yeah, we were a little under 14.4, so I'm trying to
Okay.
get as close as I can. I had it set before, but I turned the power supplies off so we weren't
and
screaming for
they
2 hours.
drift. Yeah. Okay, so running the test. Yeah, so the output is going up slowly on the AP. Wow.
All right, so we're gonna pause this for a second so we can kind of see what happened here. So according to the AP, we're at 14.24, a little under 14.4. I can change that a little bit. 4,531 watts at 1 ohm. And this is 1% THD according to the dyno, right?
Okay.
So we're gonna go over here and
So the 3600 watt amp's making 4,500 watts at 1 ohm on the amp dyno.
on the amp dyno, yeah. Now for what we're looking at here, right? So all this before here, that's before the test started, right? You just have random noise sitting here. Test starts here. So this is really what we're concerned about. Power climbs up and THD climbs up, but I'm gonna do this one more time so it's easier for everybody to see. We'll reset dyno.
Okay, so
I'd like to
second
get
run.
a clean run here. Yeah.
So there's a red line and a blue line. What's the difference?
The red line is the THD, which starts when the test starts. So you'll see it drops down here. The blue line is power. So this is microwatts, right? There's no power yet.
Okay.
All right. So now that we stopped that, pause the test.
So red is THD, blue is power.
So this is the power line. And so you can see over here, there's a number with it. This red cursor here and the 1% THD line's right here. So you're gonna take this cursor down to where we get to 1%. And then you're gonna take this other cursor over to cross it, and that'll tell you your 1% power. So in this case, at these two, it's saying right at 4,000 watts for the AP. And this is why we talk about AP power versus amp dyno power. The APs can tell you exactly where 1% is every time, over and over and over, right? We can see this. You can actually see the curve. We can expand it out in time if we want to shrink the time to make this easier to see. I can actually go in here and say, we'll stop at 25 on this one to make it easier to see. And we'll start at, when the power starts to come, 12.
So the amp dyno is showing about 500 watts more than the AP, and that's because of the accuracy. The amp dyno is more of a consumer-based product versus a laboratory-grade precision product. Is that correct?
Correct. In here, now that I've zoomed in some, so we're talking 4356. So there's 200 watt difference between the two, right? 200,
okay.
Yeah, so what we've seen in general is the amp dynos are really good at somewhere between 1 and 3% distortion.
Okay.
And that's at 14.2, right? So we're a little under power here. And we'll run this again now that we've done this to see if we can reset the dyno, reset the track.
So that difference of 200 watts is again the plus or minus, because the amp dyno is not quite as accurate a device.
Correct.
And I'm guessing that the price point of an amp dyno is considerably different than that of an AP machine as well.
Yeah. This particular AP is around 35 grand.
35,000, okay. And how much is an amp dyno?
3,900 or something like that.
Okay, so about 4,000. Okay, so yeah, so it's, for the price difference, it's a great consumer-based product, but if you're designing amplifiers for a company like Kicker, you've got to have something a bit more precise.
Yes, I mean, and that's, so like in this case, we were talking about overlap before, right?
Right.
That 3 dB of overlap equals 6.39K, right? So basically 63 almost 6,400 watts for that 3 dB of overlap.
Wow.
And at the same time, to get that 3 dB of overlap, right, you're at THD. If I can grab that cursor. It's almost, full clip at that point, right? You're at over 50% THD right here, right? So when you hit that, you're burning everything at that point. But if we go back here to where we cross 1%, which is nice and easy on this one because it's right there, you're making 5,412 watts. In this case, at 1%, but the amp dyno says 4,500.
Wow.
And so that's, did I get that right? Is that the 1% cross? No, it's not. Hold on. Let me get there. That didn't sound right. Yeah, it's right there.
It's okay, Joe. You're juggling a lot of devices there right now.
Yeah, here, hold on. It's right there. So 4489. So there we're off by about 100 watts is all in that case.
It's about 100 watts difference. Okay.
Yeah. But what you can see here is, of course, and it's harder for it to really track noise using the amp dyno as the signal than when it's using itself as the signal. But you'll see that the noise is way down here in the microvolts all the way until you start making a ton of power and start getting towards that rail, right?
Yeah.
And then this heads up. We'll do a sweep later with just the AP feeding this.
Okay.
With a normal fixed, heavy duty load because we don't want to damage the amp dyno doing repeated sweeps for it. I had the fans kicking on and going crazy on it earlier as we were testing. So this gives you an idea, like, yes, it's close. They're similar. We can do an uncertified test real quick.
Okay. Let's take a question while you're getting that set up. JW, we got a question out here. Notorious, good evening. A lot of guys been asking on the Kicker Club about running a Warhorse 3601 at a half an ohm. What does Joe say? Half ohm, Joe, what do you think?
Will it work? Most likely. Should you do it? Yeah. Do you like warranties? So the reality is because of what people call box rise, but I mean, it's really two things, right? Your speaker impedance has a single rise in it. So wherever your FS of the sub is, there'll be a big peak. So if you have a 2 ohm final load, right, you'll have 2 ohms, and then say you have a 33 hertz FS, you'll have this big peak that might go up to 8 or 12 or even 20 ohms, and then right back down to 2 ohms. You add an enclosure in there. If it's sealed, it's just going to move that around. That's what QTC comes from. If it's ported, you're going to actually get 2 humps. And so depending on where those 2 humps are, can you get away with running a half ohm DC load? Yes, but every system is going to be different, and unless you have a way to sweep and know what your impedance sweep looks like and know what your system's like and how hard do you really run it, right? There's no way to really tell you a yes or a no.
Yeah.
Because of that. One of the bigger things that you end up with is a lot of those guys that run illegal loads in the lanes roll into the volume slowly so they can get the speaker moving so the impedance is all over the place while it's playing.
Yeah.
So that's kind of a trick. And then also, let's be honest, an amplifier doesn't know what impedance you've hooked up to it.
Sure.
All we know is how much current you're pulling through it. So if your average current is under what the amplifier's protection threshold is, then yeah, it's going to work. If it goes over that, though, it's going to shut off. And in our amplifiers, right, it's just going to shut off.
Yeah.
You're probably not going to damage it. It's going to shut off. And if it shuts off 2 or 3 times, you probably should quit doing it because that is there for a reason, to protect the FETs and the output devices, right? So if it's shutting off, it's because, it's protecting itself. Well, if it's protecting itself, it's doing it so you don't damage the amplifier. It's not like we put the protections in there just because we want to have protection in there. It's there. It's there to keep the output devices safe, right?
Yes.
So if it does, so all I can really say is if you want to do that, you can try it. But if it shuts off, you probably should quit doing it because if you keep shutting off over and over and over, it's just like if you take your clutch in your car and take your motor up to 6,000 RPMs and drop the clutch. Can you do that? Yeah, but sooner or later you're going to burn your clutch out.
That's right.
The same thing is going to happen to those FETs or that power supply, right? And so you'll limit the life of that product.
Yeah, good.
Is that a fair answer?
That's a great question.
It's not politically correct, but at least halfway in there.
Joe, we don't bring you in here for your politics.
Okay.
We bring you here for your technology, man.
All right, so here is an uncertified dyno run. We're going to do the same thing. I haven't personally done this yet with the AP hooked up, so we'll see what this looks like.
Okay. We might let smoke out tonight, Joe.
I don't know. We're about to find out.
Okay, it's happening. It looks like a race.
Yeah, so let's see here.
What do we got? We can't see the amp dyno screen at all. It's too dark.
Yeah, it's 55, 52 at 14.3. We got voltage a little closer to 14.4 this time. And according to us, you're making, at 1%, once again, 4,487. Like, that's the one thing with an AP machine versus an amp dyno, right? The number is almost the same every time, unless the amplifier's gotten hot. Now let's see, where do we make 5,500 watts? So 55, 52. So we got 55, 35, right about 10% THD. So if I had to guess, I would say they're trying to look at like 10% THD for their uncertified.
Okay, so let's recap that. So the amp dyno is allowing for approximately 10% total harmonic distortion to give us that dynamic power. Is that correct?
The uncertified
okay.
number.
Okay, and then the AP is showing us, it's about 10% THD at that point.
Yeah, so the AP, we can look all the way up. I mean, if you look with the AP, with that 3 dB of overlap, so that's 5,500. In the end, we were at 6,450, so 6,500. Wow. Right, 6450 right before it cut off with that 3 dB overlap.
Okay.
So that tells you even with 3 dB of overlap, you can drive your amplifier way into its distortion.
Yes.
Before the signal disappears, in this case, you can get to a little over 50%, almost 60, with that 3 dB overlap. So overlap you got to be careful with, right? It's something we use every day in the field. But once again, you can ask an amplifier to make way more power than it's actually capable of making, and what happens with that is you get THD, right? The THD goes up.
Yeah, and like you said earlier, you may not even be hearing that distortion. Your sub sounds loud and good, but your amplifier is putting out so much more power than it's rated for, you can cook a coil.
Yeah, and so I did a bunch of testing with this back in the day with listening tests and asking people to raise their hand when they could hear THD. On a really good set of mids with a really clean amplifier, most people are between 3 and 5 to 10. I mean, I would really say most people are 5 to 10, but I'm trying to give the benefit of the doubt.
Sure.
On a sub, it's usually 15 to 30.
Yeah.
And in this case, if you were at 15 to 30% THD, you're making, let's say, at 20% THD, you're making 6,500 watts out of a 3,500 amplifier. I mean, now obviously this amplifier makes like 4,500 watts.
Yeah.
We're calling it a 3,500 one because we like to have a ton of headroom on our products, and this is definitely an amplifier that should have headroom.
Sure.
So this is, I would say, a 4,500 watt, 4,400 watt amplifier normally, and you're asking it to make another 2,000 watts at that point.
Yeah.
Right, and so you're going to be running in the THD, but that's also why when people start actually using clip indicators, I recently just had a long discussion with a guy, in the forum about how his new 1,200 watt amp seemed quieter than his 600 watt amp, right?
Yes.
And it's because most amplifiers that didn't have clip indicators, people just use the gain knob as a volume knob, right? They turned it up to where they thought it was loud enough and it sounded good and they went on their way, not understanding that it was clipping a lot because on the sub you can't really hear it.
God, Joe, it's funny you say that because when we first introduced the KX amplifiers with the input clip indicator, during trainings, I had this conversation a lot. I took out this amplifier and I put in this amplifier, and now the system's not as loud. Why? And it's the exact thing you just said. It's because you've been so accustomed to listening to distortion, you didn't realize that the system was distorted, clipping. So now that you've got an accurate way to set the gain properly, everything sounds quieter. So we have to retrain our brains, our ears, when we go to that actual true setup.
Yeah, everybody thought 1,000 watts was way louder than 1,000 watts.
Yes.
That's the reality, yeah. So at this point, I can do either one or two things. I can set this up to run the AP stuff, but I think it'd be better to do the 1004 real quick, same type of test.
Sure, let's do it.
And then, but I'll need a couple minutes to set it up. So if you can ask a couple questions or answer something, I'll swap everything over here.
Yeah, go ahead. I'm gonna mute you so I can just talk to the audience. So we're gonna take a couple questions while Joe is setting up the next test. So first question we got, Life of Tim. Good evening, Life. Thanks for being here. How much they cost? That's a great question, and I'm sorry to say I don't actually know the price of them. Hey, Ernie, do you have any idea what the price is?
No.
You do not? Okay. So the pricing is not yet published, but I bet if you call your local kicker retailer, they could probably fudge your price for you. So yeah, give them a call. All right, next question. That guy, good evening, that guy. We've seen the Z models, the K models, the C and CX models. What'll be up next? Well, these are the WX. So it's WX models, so there you go. Good question. Simple answer, I love simple answers. Next question. Arnold, good evening, Arnold. Thanks for being here. When will they be on the website? They'll be on the website as soon as they're ready to go to our local retail partners. And from what I've been told, the latest is late June is when you can expect the base amp. That's the 3601. And late July is when you can expect the 4-channel, the 1000.4. So late June on base, late July on mids and highs. Good question. Thank you. Next question. 25 hertz. Good evening. Will we ever see a 5-channel Warhorse? I won't say never, but it's not likely. When you think about this classification of product, this is the extreme, this is the premium, this is for the guy, the girl that's building a massive system, and they're probably got a giant amp rack, and you've got your DSP, multiple subwoofers, lots and lots of mids and highs, and so a 5-channel amp is really more of a one-size-fits-all solution for regular folks, guys like me. Guys like me love 5-channel amplifiers. I got my front stage, my rear fill, and my subwoofer. Real simple setup, one package, easy to install, easy to tune. So a 5-channel amplifier is a great solution for a simple system, but these are really designed for more extreme systems. I won't say never, but probably not. Great question. Next question. We got any more questions? No? Oh, for Joe? Oh, Notorious, let's see if I can answer this. This might be a Joe question. Are the potentiometers on the Warhorse amps tighter than the KXA amps? That is definitely a Joe question, but I think what you're getting at is under extreme SPL with intense vibrations, are these pots, are they going to be creeping? Remember the competition mode. The whole purpose of competition mode is to simplify the setup of the amplifier and to make it much more reliable. Joe, the question I just got was, are the potentiometers on the Warhorse amplifiers going to be tighter than those on the CX or KX amplifiers? So I was discussing the competition mode and how we specifically designed those pots to be taken out of the circuit when you're in competition mode. Anything else to add to that, Joe?
No, that's the biggest thing. Whether we have, so pots are created by having two partially resistive surfaces sandwiched to each other, and as you turn them, they get more or less resistive. Most pots have 3 legs, and one leg will get less resistive, the other leg will get more resistive. You can only sandwich them so tight to still allow them to be able to be turned in the small material that they're made in, right?
Sure.
There's pots with little click locking tabs in them that we've used before, and we actually use that on the bass knob for the Warhorse, so that it'll stay wherever you put it. The problem with that is you limit how perfect you can set the gain, because it's not ever going to be, it's only every detent, and so every detent jumps an area that you might want.
Right.
So we don't traditionally use those in gain or crossover stages because of that. Because a little difference, like setting the gain today, you guys can't see it, but I was having to match on the 4-channel, the rear 2-channel gain and the front 2-channel gain. And I originally set them by, just looking at them, like, okay, they look like they're close. Yeah. And then I ran a power sweep, and I was off by hundreds of watts.
Oh, wow.
Right? And so between the variance between pots and that, it makes it really hard to do that in a gain stage, which is why we have the comp mode for these type of amplifiers, to just remove them out of the stage altogether. Because even between channel 1 and channel 2 in a pot, there's some variance, right? So if a pot's a stereo potentiometer, it's going to have, multiple, it's going to have 2 sets of outputs. Even the measuring between those two, you'll have like a 5 or 10% variance depending on how good a pot potentiometer you buy. And so there's always going to be some variance. And so our goal with the comp mode was to make everything identical, right? We take all of that stuff that has large variance in it, in our opinion, out, and gives you a fixed signal path through that is repeatable over and over and over.
Okay, good. I gave him the 5-cent answer. You gave us the $5 answer.
That's typical. So now we have the 1004 set up, and as the amp dyno can only test 2 channels at a time, we're set up in stereo mode, which means we have the amplifier bridged with a 4 ohm load being supplied by the amp dyno. So this you could divide up. So this is going to be basically what we call max power. And I hate the word max because a lot of people use that in a way, but this is going to be your most power out. The same amount of power can be had in 4 channels, just divide it by 4 at 2 ohms, or this is bridged at 4 ohms, okay? Makes sense?
Got it.
All right.
4 channels bridged to 2 channels stereo.
Yep.
Into 4 ohm load. And we do not want to go to a 1 ohm load when bridging the amplifier into stereo. So keep it a 4 ohm load.
Yeah, this amplifier is stable at 2 ohms, so when you bridge it, you see half the impedance, so that is a 4 ohm load.
And with this much power, you might really want to use an 8 ohm speaker anyway.
Yeah, this is going to be, that'll be the fun part. I really kind of want to see how people use these. So, amp dyno power at 14.46. That's about as close to 14.4 as we can get. 947 watts one channel, 954 the other.
Wow.
If you look at the graphs over here, 1% is right there. And so 1% power is right at 1K. So we're within 60 watts this time.
Wow.
We're right at 1,001 watts is what we are at, right at 1%.
Wow,
So,
okay.
So
that's
this is,
lot.
we call it a 1,004, but it's really,
And almost 2,000.
almost a 2,004. Yeah. So we will do this same test with Uncertified.
Okay.
Might as well, since how we did it on the other one. I haven't done that before on this one either, so let's see.
That's okay.
Uncertified dyno.
Let's take a question while he's getting it set up. Got a couple more questions from the audience. JW is finding his favorite next question. Oh, I thought we had a question. Maybe we don't have any more questions. Okay.
All right, well, I'm ready if you are.
Oh, okay, go ahead, Joe.
All right, start dyno, track 9. Let's go. Start the recorder.
So this is Uncertified, which is allows for about 10% THD.
From what we saw before, yeah, this is the first
Okay.
time, like I said, anybody's ever probably logged an AP on an amp dyno to see really what they're looking at.
Okay.
So it says basically the same power, 955, 951. Let's see if we go to 10% here like we did before, what real power is. About 1,137 watts. So in this case, the amp dyno didn't really change where it was looking at. It still seems to be looking at.
Interesting.
Oh, over one more, right there.
So you're looking for 10% THD?
Yeah, 1% THD is about that same number as they're showing here.
Okay.
So for some reason and I wonder if it has to do with how fast it can read the 1 kilohertz versus the 40 hertz tone.
Oh, yeah.
So let's try this again with the 40 hertz tone.
That's a good point, Joe.
As this sample play both, right? Because there's a capture rate on every product, right? So
Sure.
Let's reset this. Same exact test. We're just going to use a different tone.
So we're going to use a 40 hertz tone while testing the full range amplifier. So this is a pretty brutal test for a full range amplifier.
Yeah, about as hard as it gets.
So and this is important to understand that a lot of amplifiers are not going to make the same power at 40 hertz as they do 1 kilohertz. So this is definitely a brutal test.
So I'm about to do it one more time to try to capture THD along with the power. There we go.
I wonder if my friend Aaron, I've got a friend Aaron out in Minnesota who's having a birthday today. He's probably not watching us live because he's probably celebrating with his family, but Aaron, if you're watching, happy birthday! I won't sing the whole song because he's got his headset on.
Yeah, I got a headset on, please don't.
I will not sing. But Aaron, happy birthday.
So 942 watts at 1%. They're
Wow.
showing 990. So that would be
About a 50
right about there, which in this case would be right at about 2.5% on this amplifier.
Okay.
You know, so it's kind of hard. Like I said, I mean, this SMD dyno is really great at what it does. Like, it's good at showing you somewhere between 1 and 3%
Yeah.
on certified. Uncertified, I'm not quite so sure what they're actually looking at for THD to get that number, because they're using the same track, the same signal, but it seems to be different on one amp versus another as to what number you get.
So, like you said, perhaps the capture ratio.
Yeah, it could be, but we just use 40 hertz the same, so I don't. Yeah, it could. It could be the how fast it can adjust to the power levels. Right, this is a lower power level.
Oh yeah.
Yeah, it's 1,000 watts and it's not bridged, whereas the other one we have to bridge the inputs on the amp dyno to be able to accept higher power.
Okay.
For mono, so it could have something to do with that. Either way, the amp dyno gives you a pretty good idea of what you make right about when you're hitting clipping, right?
Yeah.
It's not as repeatable as an AP, nor can you like see the power curve or the THD curve like you can on an AP, but it gives you a good idea. It's a really good consumer grade piece of equipment. It's much easier to use for somebody that doesn't want to have to dig in and learn how to set up all the panels and features and stuff that you can on an AP to do a bunch of the other tests. So with this, there's one thing I wanted to talk about before we get into the AP test, which I'll need a couple minutes to swap over some wires.
Sure.
I had sent a screenshot. There's been a bunch of discussion of amplifier efficiency on the Warhorse.
Oh yes.
And as you can see with the signal, as we showed you earlier, the signal for the amp dyno is not a constant signal. Like, it grows and gets bigger, and depending on where the amp dyno sees its 1% number versus the current draw at that time, there's a lot of give and take there. So how we get power efficiency numbers is by running a steady state sine wave at rated power, or at 1% power is what we normally do. And we will do the math and you'll get a power number. That power number is repeatable every time. In this case, I sent you a screenshot of the averages of 4 amps that we tested. And so there's two results there, because there's slight variances and you could average those together and get the, whatever the total of the 4 was. But they're all pretty close.
I gotta find that now.
It was the second one I sent you, so it was in a separate email. It came later.
Do you remember the title of it?
Efficiency.
Oh, 3601F.
Yeah,
okay, there it is. I got it.
Yeah.
Okay, Ernie, can you pop this up, please? See if I can zoom in on this. Okay, Joe, it's up there. Go ahead.
Okay. Well, I don't have the image anymore, so you have to correct me if I'm wrong, but on average at 4 ohm power, which is where most amplifiers are rated for efficiency, so like if you see in a document somewhere the 4 ohm number, whether that's what you're using it as or where you'd really be used at, that's normally where you'll see the efficiency number at. I think on this amplifier is 88, I believe.
88.09%, correct.
Yeah, and on average of all the hundreds of them that we've made at this point, or almost into thousands at this point, I think we've made, they're all right about there.
Let me recap this, because this is impressive. So at 1% distortion, rated at 4 ohms, this amplifier is almost 89% efficient.
Yep.
Wow.
Now the drawback, and this is something we don't talk about a lot, right? But every time you drop impedance,
Yes.
you draw more current.
Yes.
As you draw more current, more energy is lost to heat through the power wire, through the PCB traces, through the inductors, through the transformer, through the FETs, even through your speaker, right? Your speaker turns more stuff into heat. So all of that adds up to your efficiency number. And if you can get away with it and make more power or have a bigger amplifier and run it at a higher impedance, you're going to be easier on your electrical system, you're going to be easier on your electronics, and like as long as you can do that, that's great. If you can't, right, then load it down and go.
Right.
But as you load it down, you'll notice, so 2 ohms, you lose about 4% efficiency or so as you head down that path.
Right.
And once again, you lose another 6 or 7% efficiency when you go to 1. And that's just laws of physics, right? You'll have some amplifiers with an amp dyno that'll test better than that. But normally what's really happening is there was energy either stored in the transformer or bulk caps or somewhere else, or the current meter, which, as we talked about earlier, meters always average. Even if you're doing peak hold, you're missing a little bit of data there. So the amp dyno efficiency test numbers are, like Big D said in his latest video, they're there as a reference, right? They're not perfect. They're not going to always be the same. Like you could test the same amplifier over and over and over and get different numbers,
right,
depending on where it pulls the stuff from. So if it's a good bar to crawl over to get an idea of, but it's really not something you should set as a reference. And generally, amplifier efficiency is really less important about how efficient the amp is versus how hot the amp gets, right?
Yeah.
Because what will kill the amplifier is not being able to get that heat out of the FETs, getting the heat out of the heat sink, getting that heat away from the devices that create it. That is the important part.
Yeah.
And anytime you can stay around 80%, that means only 20% of the energy is being wasted somewhere else, which is heat, right? Light heat. You only got a few things you can turn into.
Right.
So in this case, like the lower we can keep it, the better. To be honest, we probably don't really need the fans on the Warhorses. They don't really get that hot, but we know how these are going to be used in the lanes.
Yes.
And so we really wanted to make sure that these things are very robust.
The Drew Joneses of the world are going to abuse the amplifiers, so we built them for the Drew Joneses. Okay, so Joe, you're going to switch over.
I need a couple minutes to switch over to all
Okay.
AP stuff, and then you guys can cut back to me, and we'll do a couple AP tests, and then we'll take some questions and go from there.
Okay, we've got quite a few questions. Questions hopefully that I can answer. I don't have Joe's big brain, but Overkill, good evening. Thanks for being here with us. Kicker ST woofers are rated at 250 RMS. Is that for the pair speakers? It's 250 RMS per speaker. So you've got two 7-inch, which is rated at 250, and the 9-inch are rated at 300 RMS. And so yes, that is per speaker. And we did that because we knew that these are going to be very high-powered systems. And if you're going to be running almost 4,000 watts to the subwoofer, you're going to need an awful lot of front stage to keep up with that. So we decided to make them very high-powered, but still high sensitivity. Again, sensitivity is how loud can I play with a given amount of power. So generally speaking, the higher the sensitivity, the louder they're going to play with that amplifier that you've got to work with. So that's a great question. I'm going to mute Joe real quick. Next question. Same gentleman, thank you. Would you recommend 2 Street Series 7s on each channel? Yes. Oh, yeah, Joe, sorry, I muted you because didn't want to chat in your ear. So the answer is yes. You can use a pair of the ST7s on 2 channels of the 2004, or the 1004. Now, remember, it's got the high-pass filter built into it. And so for the Street Series, what you could do, if you wanted to, is use the 4-channel with the fully active system doing high pass for just the tweeters, and then do a low pass for the mid-range as well as a high pass for the mid-range. So effectively doing a band pass on your mid-ranges and then a high pass on the tweeter. So you could use all 4 channels to do a fully active system with the Street Series 7 and the tweeters. So that's one way to do it. You could also just do a whole wall of mids and tweets and use the passive crossovers that we include with them. So great question. Next question, what do we got? Andy, hello! I'm going to ask about the elephant. The horse in the room. Good one, I see what you did there. Well done. Estimated arrival date for each Warhorse. Andy, we covered this earlier. You were probably in the restroom. So the bass amp, the 3601, we're looking at the end of June, which is next month. And then for the 4-channel, we're looking at the end of July. So end of June, end of July, that's when we're expecting to have them available at our retail partners. Great question. Thank you, Andy. Next question. Jason, good evening. Q, question, are the ST speakers part of the Warhorse family? That is a great question. So we have what we call the Pro class. Pro class is Warhorse amplifiers, ST Street Series, mids, and tweeters. The installation components, Warhorse installation components, and of course Solo X subwoofers. So that is the family of Pro class. And so all those are designed to work together in perfect harmony and fantastic high output systems. Great question, thank you. Next question. Jason, hello again. Are the Warhorse accessories still coming? Yes, and I should have brought some to show you tonight. I apologize, that's my failure. I've got a box of the Warhorse accessories that I used for our training a couple weeks ago. So yes, they are coming and they're going to be available at the same time as the amplifiers. So you can get all of your Warhorse installation components at the same time as the amplifiers. Great question, thank you. Next question, what do we have? Anything else? If not, I have a Warhorse install scenario document, and this is something that we have to be talking about. So the basic installation requirements for a Warhorse amplifier, if you're going to run a single 3601 in your system and you want it to run properly, we have some bare minimum requirements. At idle, you need an amplifier, you need an alternator capable of 180 amps of output at idle. And that, of course, is to charge the batteries to power the amplifiers. You need, of course, the Big 3 upgrade. So you absolutely need to be upgrading the electrical system in your vehicle with an alternator and the Big 3 upgrade. We need 2 aught gauge power and 2 aught gauge ground. Now this is important to understand. When you look at the amplifier, there are 2 positive and 2 negative aught gauge terminals. And these are not for daisy chaining amp to amp to amp. The amplifier requires 2 aught gauge power and 2 aught gauge ground per amplifier. And you need to be fusing these at a total of 400 amps, so that'd be 200 amps per positive leg. In addition, you need a second battery, which is very, very close to the amplifier, a second battery with 80 amps or more of current capacity and 800 cold cranking amps. So yes, you require a lot of electrical system to power up this amplifier. I like to say that amplifiers don't make power. They don't make power. They simply take your 12-volt electrical system and step it up to whatever it is that you need for your rated output. And how do they do that? Current. So they take current, lots of current draw to take that 12 volts to whatever it is that you're looking at for your rated output. So you have to have the electrical system to back up the amplifier. And we know we're going to get these calls at tech support. Well, I've got the 3601, but it keeps shutting off. It doesn't work properly. The diagnostic keeps telling me low voltage. What's going on? Check your electrical system. If you don't have the electrical to back it up, it's not going to work properly. And that's why I was talking about earlier the 1000.4. The 1004 is a great way to get Warhorse amplifier technology in your vehicle with minimal upgrades. So let's talk about the upgrades you'll need for a WXA 1000.4. Again, I suggest running it in 3-channel mode. So you've got 2 channels running stereo for your mids and your highs. The other 2 channels bridged to a single 4-ohm load. Now with this setup, in most cases, you could use a stock alternator, assuming it's a high quality factory installed alternator, not a car from the 70s that's been run for 400,000 miles. You still want to do the Big 3 upgrade, of course, and you're going to need a single 0 gauge OFC for the power and for the ground. So the mono amplifier has dual aught gauge input power and dual ground. The 4-channel has a single aught gauge input, single aught gauge ground. So you're going to want to run true OFC, which of course all kicker components, installation components are oxygen-free copper, single aught gauge in and out, and then 200 amps of fusing. So in our installation components for the Warhorse amplifiers, we do have a fused distribution block. You'll need a single 200 amp fuse for that 4-channel amplifier. So there again, that way you could run a single Warhorse 4-channel, have a fantastic high output system with minimal upgrades to your charging system. Joe, how are we doing in there? Getting close? Okay. Do we have any more questions? We can take more questions. Baba, good evening. Thanks for being here. Was the price of the Warhorse installation kit announced? No, not yet, and it's not a kit per se. You'll need to choose whichever installation components you'll need for your particular system. We do have aught gauge power and aught gauge ground wire, and then various distribution blocks depending on how many amplifiers you're going to add. So it's not really a kit per se. You kind of have to put together the pieces that you need for your system. But those prices will be available when the amplifiers are available as well. Great question. Thank you. Next question. Adam, good evening. Thanks for being here. I don't know, but what about sound quality? I am hoping for an improvement on KXA sound or a continuation on sound quality. So that is pretty much what we've been talking about for the first half of the show. The specifications, particularly on the 4-channel amplifier for your mids and your highs, the specifications are fantastic. Even though the amplifier makes truly almost 2,000 watts RMS, it is very quiet. The signal to noise is huge. Signal to noise again means how much signal is coming in versus how much is coming out, and how much noise is the amplifier making on its own. If you can hear the amplifier making noise, you have a low signal to noise ratio. So it's very, very quiet. In addition, Joe is showing us the FFT. That tells us when a signal comes into the amplifier, how much noise is being generated by the amplifier that goes on top of that signal. And the amplifier is incredibly quiet, and it's not making any of its own noise. So even though it's capable of some very high outputs, it is not going to be a noise generator. Good question. Thank you. Oh, ready. Okay, Joe's ready. Let's go back to Joe in the lab. All right, Joe, what do you got for us?
All right, so we're set up basically with a 4-ohm bridge load on the Warhorse 1004 again. And this would be more of our traditional power sweep that you would see with an AP. So what we'll do here is we'll kick on the signal. We've got it set up to do 25 points and 1 volt to 6 volt signal. So we should go into clipping here. So we're gonna start this. And you're gonna be able to watch power over here in watts. So you're also gonna be able to watch THD versus power as this goes up here.
Okay, so it's bridged into a 4-ohm load. We're using the 1000.4.
Yep, so obviously signal to noise or THD ratio, we start out 0.01 all the way across, pretty much stays there. You're at 400 watts, it starts to climb, 500 watts. In this one, we made it all the way up to say, 9% THD, and in that case, you're at 1100 watts a channel.
1100 watts at 9% distortion.
At 1, you're right about 1K. We're 970 here, and it's a little higher than that, but because I only did 25 steps for time,
wow.
I can't quite get right to 1%. But if you look across this, right, all the way from low power up, it's a very clean signal, low THD. We're talking 0.1, not 1%, 0.1 all the way across.
Inaudible.
Yeah, inaudible. Nice and clean power. If you look at the monitors and meters, right? There's your sine wave, right? You can see it. I've got one of the channels hooked up backwards, so sorry about that. On the sense leads. But you can actually watch the THD come here. You can watch the frequency here. Once again, you can see the power and the harmonics over here on the FFT.
So this goes directly, the last gentleman who just asked the question about sound quality, this is exactly what we're talking about. This amplifier is incredibly quiet, so it's going to sound amazing at low and very high volumes.
Yeah, so here you're looking at almost plus 25 dBu for the 1K signal, and you're at negative 42, 43. So you've got over a 65 dB before you even see your next harmonic, even at almost 50 watts output.
Yeah, you're never going to hear that.
No, and something you don't normally see is like people will run, normally most of the time you'll see an FFT, it's a 1 watt FFT. Realistically, with a mid amp, even one this powerful, you're normally running somewhere between 10 and 50, 60 watts overall power, because once if you put a high pass crossover 100 hertz, the way the music's recorded, that's, the dynamics are there, but that's what you're getting.
Yeah.
But we'll go ahead and run this up a little bit so you can see. You see what happened there when the AP changes, you got a bunch of noise, but in general you see that it just keeps climbing and you keep the same difference between the two. So very clean, there's 100 watts already, you're still at plus 30 and negative 30, so 60 dB different between your first harmonic and your first, which is 2 times what our bass knob will turn down the power. So as you can see, very clean amplifier, very quiet amplifier.
Very nice.
We can do the same thing with the 3601, and then we can even try, some different loads if you want. I just need to switch over a couple wires real quick. It'll be quicker than last time. But
yeah, go ahead. I'll take some
take me a
more
minute.
questions.
All right.
Go ahead, Joe. Thank you. J-Dub, we got some more questions we can... Oh, sorry, I stood up on you. My butt was getting tired of sitting. Overkill, good evening. Again, I think third or fourth question. What kicker amplifier do you recommend for the new ST tweeters? Well, there you go. So the new Street Series tweeters, of course, they don't need 250 watts at 4 ohms, but we absolutely want to use the Pro class together as a family. So we'd prefer you use the Warhorse amplifier with your Street Series tweeters, but you could always use a CXA 360.4 that is more than enough power to drive those tweeters to full output and sound great doing it. Of course, one of the main benefits of the Warhorse, other than the fact that it's a lot of power, it also has that built-in ×10 multiplier on the crossover section, so you can go fully active and not have to use the passive filters at all using the ×10 multiplier. Now, you could also use one of our KXMA marine amplifiers. Those amplifiers also have the ×10 multiplier, so you could still do a fully active system using the KXMA. So we have quite a few choices. Great question, thank you. Next up, Andy, we're back to you. Thank you, Andy. What are the power wire input sizes for the 1004? Great question, Andy. It's aught gauge, 0 gauge input, power, and ground. So the 4-channel needs a single run of aught gauge OFC, oxygen-free copper, for the power and the ground. And then the 3601 needs dual aught gauge power, dual aught gauge ground. Great question, Andy. Always thinking. Next question. 621 Electronics, good evening. Thank you for being here. Would Kicker ever consider offering recones for cheaper subs? It's nice knowing that you can recone a smoked sub for a lot cheaper than a new one when buying a brand, even the budget subs. That's a great question. One of the challenges with recone is, of course, if you do it yourselfer, if you do it yourself but you don't do it properly, you can have a really bad experience. Engineering a sub from the ground up to be reconable by a typical consumer is very challenging, i.e. expensive. I won't say never, because we've already changed a lot of things in the industry in the last 50 years, but I suspect you're going to see that more on the premium subwoofers and not so much on less expensive subwoofers. So thanks for asking the question. It's good to pass that along to our engineers, because we absolutely want to consider all aspects of great customer service, and that is certainly one of them. So thank you for that question. Good question. Next up, what do we got? 25 hertz, good evening. Are we going to see a Warhorse specific component system for the 4-channel Warhorse amplifier? Glad you asked. Street Series. Again, Street Series mids and tweets, those are part of the Pro class. So the Pro class is the Street Series mids and tweets, Warhorse amplifiers, Solo X subwoofers, and Warhorse installation components. So that is, the answer to your question is Street Series. And I just heard Joe say he's ready to go, so we're going to go back to Joe. All right, Joe, what do we got?
All right, so now we have the 3601 hooked up to just the audio precision. We'll run a sweep here from basically no power all the way up to hopefully around 10% THD with the gain settings we have now. So here we go.
Right.
You'll see this climb as this goes up.
500, 600, 700, 900, 1,000.
Still at 0.03 distortion.
Wow.
2.9, still at 0.04 distortion.
Unbelievable.
A little almost 7,000 watts.
7,000 watts at what percent distortion?
I have to get the cursors out here. Hold on.
This is unbelievable. These numbers are so unbelievable, Joe. It's like my brain almost can't wrap around how much power we're talking about.
So that's 7,490 watts at 6% THD.
6%.
6.3% THD, something like that.
Completely inaudible, 7,000 watts.
That's 7,500. But yeah.
That's just
You
amazing.
want to get technical, 7,500.
And look how small this amplifier is. That's just huge power from a small footprint. Man,
So,
Joe, your team is unbelievable.
makes really good power. What I like to do, well, I like to look at, and what is more impressive to me in this power range, and I don't have a competitor amp here to test that we could put under a tower
Next
or
show,
box,
the next show we'll do it.
is most of the full bridge amplifiers that you see in this realm, all right, SPL,
Yeah.
will start out when you start sweeping them at like 1.5%, 2% THD, then drop to just below 1, crawl across here, and then angle up at an angle, right?
Okay.
Because that's not what they're really designing. You know, they're not caring about how it sounds, how
Right.
clean it is, how much, you know, what that type of stuff. It's just cheap power. For us, like, you know who we are, right? We're never going to do anything that way. All of our stuff has to be clean, sound good, make power, be reliable. Like, these are our goals, right? We have a fixed set of beliefs, and that's always going to be what we can do. But to me, what's most impressive about the 3601 is this. We were talking about what a perfect amplifier would look like.
Right.
This is pretty much what a perfect amplifier looks like. Like when we're designing an amplifier, if we can get a THD curve like this,
Yeah.
this makes us happy.
Yeah.
Right? Because getting something that is nice and flat all the way up to 4,500 watts before it hits the power wall and starts to climb, right, is very hard to do. This takes a lot of work. And in this case, it was done very, very well. And every time I see this, like when I first saw this, I remember this was, well, COVID time.
Yeah.
When I first saw the prototype and we did the test and he sent out the graph, and I'm like, are you sure? Right? You know, it's a lot of power to have a graph like that. And then I went and grabbed it and tested it, and I'm like, yeah, never mind, he's sure. Like, yeah, so this is really a well-designed amplifier. And things that this doesn't show you is this means that your spiking is low, your THD across the board is low, you're not getting anything radiating into another part of the amplifier.
Yeah.
Right? It means all those things were taken into consideration and done really well. This is a very nice curve. This is one of my favorite, to be honest.
That's incredible, Joe.
And overall, you know, we added 4 more output FETs right before the end of development, which delayed us a little bit, just to make sure this thing would be bulletproof, reliable, and being able to share current across more devices in those cases when people are running it, you know, maybe illegal loads or
Yeah.
harder than they should. And to a point, we haven't had, you know, anything that I can complain about on this amplifier. It's been a monster. So, questions, comments, anything anybody'd like to see?
Yeah, we've had quite a few questions we've answered. Do we want to take another couple of questions for Joe and then let him go home? Because we still got a few more things to cover, like giveaways. So a question for Joe. JW, got anything hard? 25 hertz to life. Joe, can you give us ratings in the high 12 volt range? Some of us have a good alternator, but not a mech man.
How about we just do that real quick?
Oh, perfect. So we're going to run the thing at 12 volts.
Let's say...
Side note, these amplifiers are start-stop compatible, which means with vehicles that shut down at red lights and then restart when the light turns green, you let your foot off the brake, these amplifiers will not shut down. They'll just keep working. So that's incredible in itself. So Joe, you're going to run us a 12 volt?
We are at 12.8 at the power supplies. That will be around 12.6 to 12.4 at the amp. About as close as I can probably get to real battery voltage for him.
So 12.5. How much power we got?
Well, we still get to 6,300. Let's see what we got at. right, so at 1%, we just crossed.
So 1% total harmonic distortion. How much power?
I can't quite get the thing on it. 40, probably about what our burst sheet says, or a little under. It's pretty close.
So about 4,500 watts at 12.5 volts.
So still getting good power out of it. Your THD is a little higher. Right, we're at 0.3, 0.5, and we turn the corner, but still very, very clean.
Still, you cannot hear that level of THD. Okay, good question. Any other questions for Joe? Really hard questions for Joe?
Oh, let me run that test one more time. Hold on.
Okay, Joe's going to run it. So Josh is asking, can I use my matrix to put 7 volts into 3601? Yes, good question. So the amplifiers have a 40 volt input. It's our Fit Plus technology. So up to 40 volts, which essentially is 400 watts at 4 ohms. So no problem. 7 volts, no problem at all. And like Joe said earlier, the higher the voltage coming into the input section, the less gain we need, the less sensitivity we need to make rated power. So the more voltage you can put into the RCA inputs, the better off you're going to be, assuming it's clean voltage. So yes, you can use that. Good question. Thank you. Next question.
About 3,500 watts or so at 12 volts.
3,500 watts at 12 volts.
12.48 or so.
So 100 watts less than rated power at 12 volts at what percent THD?
Oh, no, this is 3,400, 3,500 watts. So that's, well, yeah, I guess we call it 3,601. Sorry, I always think of this thing different. Yeah.
It's okay.
So at 12.4 at 1%, it's 3,300 and some change. 3,300
watts,
yeah.
1% THD, 12.5 volts. Got it.
At 10% THD, it's 4.2.
4,200 watts.
Yep.
Okay, so still plenty of power. Got it. Very efficient amplifier.
And let me run one more 14.4 because I had one load missing originally. That's why the number seemed weird to me.
Okay. Let's take another question while Joe is running the test again. Overkill, good evening, Overkill. You are working overtime tonight. So the ST tweeters can handle 250 watts RMS? No, please don't put all 250 into them. So when you're setting up your system, you're going to want to run the tweeters much closer to their average rating of 50 watts RMS. So you're going to want to use your voltmeter set to AC, and you're going to want to use your 1 kilohertz test tone. And you want to be sure that the output of the amplifier, you have to use the voltage chart to get the right numbers. I don't have them on top of my head. But there'll be a specific voltage number at 4 ohms, or you're running at 2 ohms at 2 ohms. That specific voltage AC at 1 kilohertz will give you your proper output power into the tweeters. Great question. Thanks for asking it. Sometimes I forget that if you're going to be running just tweeters, you want to make sure to gain the amplifier appropriately, rather than running the mid-ranges, which can handle all 250 RMS. So great question, thank you.
So yeah, 4,500 and 56 at 10%. So about what we talked about before.
Okay, say that again, I was talking.
4,500 at 1% and almost 6,500 at 10%, right?
And that's at 14.4?
That's at 14.4, probably like 13.3, 14.3 and 1 ohm load.
Okay,
so you can get an idea on that.
Way overrated, got it. All right, Joe, that is all the questions. So thank you very much. Great having you here tonight.
Thank you, guys. I appreciate it.
And next time, we will definitely have to let the smoke out of somebody else's amplifier.
Yeah, we'll do some type of something else next time.
All right, thanks, Joe. Good night, sir.
Thank you, sir. Bye.
All right, I'm going to take off this lovely headset, and we're going to do a couple more things together tonight before we go home. Where are we? Jacob's Q&A. So Jacob, who is not traveling, but he's at home with his lovely girlfriend this evening, he sent some questions to me, and I got to find those questions now. Our typical tech questions. Here it is. First question. I have a key 200.4, and whenever I try to run the auto setup, it gives me the sad beeps. Wah, wah, wah. I've checked to make sure that all the speakers are playing, My voltage at the amp is good, and no other speakers in the vehicle are connected. What could be wrong? First thing that comes to mind, check your phase. Check your polarity, your positive and negative speaker front left and speaker front right. Make sure they are in phase. Then check the rear. Make sure all your speakers are properly in phase, and then run the setup again. That is really common. I think it's, what is it, John Myers, he's got a Journey, a Dodge Journey, and he had this exact problem, kept failing. Come to find out, from the factory, the front left speaker was out of phase with the front right speaker. You swap the phase, worked perfectly. So check that. Something else it could be, if the volume is not high enough for the microphone to hear it clearly, it can actually fail. So you might also try ramping the volume up a little bit higher. I think what it says in the manual is a little bit louder than a comfortable listening level. And that's the volume that you want to set when you run the setup. So try those two things. Next question. I just had my Comp Q 12-inch installed in a vented enclosure. I have it in the back of my Escalade. When I'm listening to music, I keep smelling a chemical-like smell, kind of like hot glue. I know that smell. I asked my installer what it could be, and he's stumped. He said he checked the amp with an O-scope and measured the subwoofer coils with the meter. Everything was normal, and the amp is not clipping. Any ideas? Sometimes new subwoofers, when you first play them and you get the coils hot, sometimes you'll get that smell. And it's kind of like the setting of the glue. So the glue might be getting hot enough that it's off-gassing a little bit. And in a vented enclosure, because you're exchanging air with the back side of the woofer and the front side of the woofer in the car, you might be smelling that. I suspect you're going to stop smelling that over time, and everything will be great. So just stay tuned, keep banging on it, and let's check back in a week and see if you still smell it. Great Q&A. Thank you, Jacob. Hopefully you're at home watching. Actually, no, let's hope you're having more fun than watching us tonight. Next up we have, oh yeah, fail picks. We love fail picks. Ernie sent me a couple of cool fail picks. Here's the first one. Again, if this is your vehicle, we're not trying to pick on you. We're just having some fun at your expense. See what I did there? But what we're doing is we're just looking at things that we commonly see, some errors. Maybe it's your first time installing, not really sure what you're doing. But Ernie, can you pull up my laptop so these folks can see this particular fail? See, look at this grounding setup here. If one screw fits, 3 is better, right? There you go. So there's your ground point. And is this even metal? Yeah, that's probably metal, but yeah, we definitely don't want to be using that as our ground. Nut and a bolt is definitely a better way to go. And the next fail, let's zoom in on this a little bit. That looks like a CS tweeter.
No, that ain't ours.
What? That's, oh no, you're right, that's not ours. So what is, Ernie, what is this? That's the crossover. Okay. So this particular installation, they wanted to show off the crossover, and so they just mounted it right next to the tweeter. So yeah, thanks for showing off the Pisaniner. Is it the Pisaniner? I hope I'm saying that correctly, the Pisaniner. So yeah, creative tweeter installation. Why not, right? So then for the cool picks, I think, yeah, actually Ernie sent these to me as well tonight. So first, check out this car. Look at this beautiful car. And then wait till you see the install. Look at that. Very, very nice. I think those are those 8s, Ernie? I think that's 4 8s. Yeah, I think that's 4 8s, some CX amplifiers. I love the way 8s sound. And then this is obviously a different system. This is a beautiful enclosure. Look at that paint work. That's just amazing. And that looks like a Comp Q 12-inch, I believe. So very nice work, very, very nice. And it looks like a KX amplifier down there too, hiding in that amp rack. Yeah, that is a KX amp, and I don't know what that is, but it's not a KX. Very nice work there. So those are our fun pictures. And I think, oh gosh, I almost said Bill Frog, who won tonight. See, Bill, you're living on with me. So, is it time to give away stuff? It is time to give away stuff. Oh, yeah, I'm sorry. My mind is discombobulated because Joe just talked me under the table tonight. So events coming up. Slamology. I saw Slamology being talked about in the feed there. You guys and girls are excited for Slamology. So are we. That is June 8th and 9th in Indianapolis. And of course, Andy is going to be there. And I think Andy's actually going to be in our tent with the XRV, so he's going to have some shade, which is always fantastic. And if I'm not mistaken, he's going to run his show live from the tent as well. So that's going to be cool. Also, we have Knowledge Fest coming up in Atlantic City. Now, Knowledge Fest is industry only, so if you guys and girls are in the industry and you go to Knowledge Fest, please come check us out. Jacob Lucky's going to be there, and he's going to be doing a couple of trainings on the Pro Class series of products. So he'll be doing a little more in-depth on Pro Class. And so that'll be in Knowledge Fest in Atlantic City. And then, of course, the Kicker Monster Truck Series also is happening. If you want specific dates and locations, go to our Facebook and go to the events tab, and you'll see where all of those events are happening. So those are the things that are coming up. Now, Ernie, can I give stuff away?
Okay.
All right. Ernie says I can give stuff away. All right, so our third place winner, in case you don't already know, third place winner, EB400 in-ear Bluetooth monitors, as well as a UnMasked t-shirt and a couple of koozies. Who is our third place winner? Drum roll, please. James M. from Georgia. James M., congratulations, you're our third place winner. Second place winner tonight, you get the TW2s. That's the new True Wireless Series 2 in-ear monitors. You also get the t-shirt and 2 koozies. Number 2 winner tonight is Dean S. from Missouri. Congratulations, Dean. I just got myself some of the the TW2s. Love them. TW2s, fantastic. Love them so much, gave one to my babysitter as well. Now she loves them. First place winner, you get the BF100, which is the Bullfrog, the Bluetooth speaker, of course the t-shirt, 2 koozies. Who's our first place winner? Chris A. from Texas. Congratulations, Chris A. from Texas. You're our first place winner. So there you have it, our 3 winners for tonight. Thank you for being here. And Andy is not doing his show tonight. He is in crunch time to get his stuff ready to go to Slamology. So no Andy show tonight, but he will be live on Friday. So be sure to hang out with Andy on Friday, and we'll see you in 2 Tuesdays, which is June 11th. We'll be back June 11th with a fun show for you. Thanks for being here tonight. Appreciate your time and your attendance, and we'll see you next time.